We're going to look at some applications of logarithms in this video. So we're going to look at some word problems, and to answer each of these questions, we're going to need to use a logarithm. So let's look at the first one here. It says, how long will it take to double $2,000 if it is invested at a rate of 6% compounded monthly? I've given a formula here that we use when interest is compounded n times per year. This is not a formula that you need to memorize, although you do need to know what each of the variables represent. Okay, so if we want to double our money, then our ending amount should be $4,000. That is twice 2,000. The principal is given as 2,000. Our interest rate is 6%, but we want to enter that in the formula in decimal form. To convert from a percent to a decimal, we move the decimal point 2 places to the left. If the interest is compounded monthly, that would be 12 times per year. So our n is 12. N also appears in the exponent. So all right, 12 again. And t is time, but we don't know that. That's what we're trying to solve. So our t would be a variable t. That's what we're solving for. We can't plug anything in for t. Now, if you'd like, you can calculate this here inside the parentheses. It'll turn out to be 1.005. You can use your calculator to calculate that. And to solve this, first of all, I'm going to mention you cannot multiply 2,000 and 1.005 because by order of operations, we need to evaluate our exponent first. But we can't evaluate the exponent because there's a variable up there. So to solve this equation for t, the very first thing I'm going to do is I'm going to divide by 2,000. Then I'll have 2 equals 1.005 to the 12t power. 2, it's good I got 2. That makes sense because up here in the problem, we're trying to double our money. So it would make sense I would get a 2 over here if I'm trying to double my money. Now, to solve this, I need to use logarithms. I'm going to take the log of both sides. That's kind of how we'd say it. Take the log of both sides. And I'm going to pick a base of e. So I'm going to use the natural log. Now, for all the word problems, I personally always take the natural log of both sides of the equation. This is because sometimes you really definitely want to if there's an e in the equation. But I just like to always, if I'm doing a word problem, take the natural log of both sides. That way I don't have to think about, is there an e? I mean, if there is an e, we'd be able to see it. And we are going to see one problem with the irrational number e in it. But I'm just going to get in the habit of, I'm always just going to take the natural log of both sides. I'm going to take the natural log of 2 and take the natural log of 1.005 to the 12t power. Then what I'm going to do is I'm going to take this 12t and move it down in front and make it a coefficient or a multiplier, if you want to call it a multiplier. So this is one of our laws of logarithms. We have a law that says, let me write it over here in a different color, that log base a of u to the c power is equal to c times log base a of u. Okay, so that's what I'm doing. I'm taking the exponent of 12t, I'm moving it down in front, I'm making it a coefficient or a multiplier, and this now I have t down here. It's no longer in the exponent anymore. All right, the last thing I need to do is I need to isolate my t. So I'm going to divide both sides by 12. That's one thing because I need to get rid of that 12. So I'm going to divide both sides by 12. Okay, that'll help me get rid of this here. But I also need to divide by the natural log of 1.005. I also need to divide both sides by that. So I got rid of that. Get rid of that. So I have isolated my t. T is equal to the natural log of 2 divided by 12 times the natural log of 1.005. Okay, now let's type that into our calculator to see what that is approximately equal to. So I'm going to pull up my calculator. Now this is a graphing calculator, which you're not allowed to use. This is my only calculator that I have. It's my good virtual calculator here. However, I won't use any of the graphing functions. I'm going to type it in just as you would into a scientific calculator. So I'm going to hit this ln button, which is natural log. So the natural log of 2 divided by, and then I do need to put the denominator in parentheses. Otherwise, my calculator is going to do order of operations. It's not going to give me the correct answer. So I am going to put the denominator all in parentheses here. Now, if you have a fraction button on your calculator, go ahead and use that. That's great if you have a fraction button. So I typed in natural log of 2 divided by 12 times the natural log of 1.005. I've got the denominator in parentheses, and I get that it's going to take me about 11.58 years to double my money. Now, it doesn't say how to round. Let's round to 2 decimal places. Technically, I should round that up to 11.59 years. This is because if I round down to 11.58, I won't quite have my $4,000 just yet. I'll be really close to $4,000, but not exact, or not 4,000 or more. So I guess the best answer would be 11.59 years. But I'm sure your instructor would count 11.58 years correct as well, because that's, you'd be extremely close to $4,000. So I'll put or 11.58 years. Now, before I go on to the next problem, let me just show you, you can do a quick check. Let's just do a quick check over here. So I started with $2,000, and the rate is 6%. It's compounded monthly. And I just said that my answer should be 11.59 years. So let's type this into our calculator, and let's see if we get $4,000. Now, we're not going to get exactly $4,000, but it's going to be really darn close to 4,000, which would mean that we've done the problem correctly. So I'm going to type this into my calculator here. So I'm going to start with 2,000. Then I know that inside the parentheses here is 1.005. So let me just type that in. And then I'm going to raise it to the power. So I'm going to take 12 times 11.59. Once again, notice I put that exponent in parentheses. You need to do that. Otherwise, your calculator is going to follow order of operations, and it won't give you the correct answer. All right, so I'm getting $4,002.08. So $4,002.08. Okay, well, we must have done it correctly because we're trying to double our money. Ideally, we get $4,000, but we rounded to 2 decimal places. So $4,002.08 means we have correctly done the problem. Okay, let's see another one. For this one, it's very similar to our last one. We're borrowing $1,000. The interest rate is a whopping 25%, compounded quarterly. And how many years will we owe? 10,000. So 10,000 is our ending amount. 1,000 is our borrowed amount, principal. The interest rate is 25%. As a decimal, that's 0.25. Compounded quarterly would be 4 times per year, and our exponent is going to be 4 times t, where t is what we're trying to find. How many years is it going to be until we owe 10,000? 0.25 divided by 4 would be 0.0625, And we can just do that in our calculator. So 0.25 divided by 4. So 0.0625, add the 1. So it looks like inside the parentheses we have 1.0625. So 10,000 equals 1,000. And then this is 1.0625 to the 4t power. Okay, last problem I mentioned, we can't multiply 1,000 times this, but we can divide both sides by 1,000. So let's do that. And 10,000 divided by 1,000 is 10. Okay, now next step, I'm going to take the natural log of both sides. It would also work to take log base 10 of both sides. I always like to just do natural log. It's going to be, I'll show you number 3. The next one we're going to do, you're going to see why the natural log is really helpful. Then I'm going to use my law of logarithms. I'm going to move that 4t down in front and make it a coefficient or a multiplier. And then to isolate t, I need to divide by 4. Get rid of the 4. I also need to divide by the natural log of 1.0625. Okay, so natural log 1.0625. All right, and then now I've got my t isolated. So t is the natural log of 10 over 4 times the natural log of 1.0625. Let's see what that is approximately equal to. We'll round to 2 decimal places. So natural log 10 divided by, I'm going to put my denominator in parentheses. And it looks like it's going to take 9.50 years if we round to 2 decimal places. So in about 9.5 years, the $1,000 that you borrowed is, you're going to owe back $10,000 for that 1,000 that's you. Now this is assuming you make no payments for 9.5 years. So you would owe back 10 times what you borrowed, but you haven't paid anything in 9.5 years. All right, 2 more here. We're going to do number 3 and then number 4. Number 3, we want to triple a sum of money. It's being invested at a rate of 5.5%, compounded continuously. I have a different formula because it mentions that the interest is compounded continuously. So when the interest is compounded continuously, we use this formula. Now, it didn't tell us how much money we're investing. We don't have a principal. But it actually doesn't matter what you pick. You can pick anything you like for the principal. And as long as you put in 3 times that amount for A, you'll get the correct answer. So it does not matter how much we invest. You could even, if you want to, maybe I'll enter A as 3 times P. So it doesn't matter what the principal is. Whatever the principal is, I'm going to take 3 times that and put that in for the ending amount, the A. So, you know, I'm going to go ahead and leave it as 3P equals P times E to this power here. But if you want to pick something like 1,000, that's fine. You just put 3,000 over here. Or you could pick 5,000 and then you put 15,000 over here. It really doesn't matter because no matter what, when we divide both sides of the equation by P, we're going to get a 3 over here. So like I said, it does not matter what you enter as your principal. When you divide both sides of the equation by that principal, you're going to get a 3. Okay, I'm going to take the natural log of both sides. And I'm going to use my law of logarithms. I'm going to move this 0.055t into the down here in the front. Okay, so here's why I like to use the natural log. The natural log of E is 1. Okay, I'll show it over here in just a second. Since the natural log of E is 1, we can just drop that. Our equation becomes the natural log of 3 equals 0.055t. And then I can divide both sides by 0.055 in order to isolate t. So I like to always take the natural log of both sides when I'm doing word problems, because if there is an e in the problem, it makes it really quick because the natural log of e is equal to 1. Okay, so this is equal to 1. I'm going to show that in just a second. Let me go ahead and finish the problem though. So let's see how long it's going to take to triple our money. I'm going to take the natural log of 3 and divide by 0.055, and it's going to take about 19.97 years. Technically, I should say 19.98, because by 19.97 years, we won't quite have tripled our money just yet. It would be close, but not yet. I'm going to round up here. Okay, or like I said, I'm sure your instructor will count 19.97 years correct as well. Just 19.98 is a better answer. All right, let's look at why the natural log of e is equal to 1. So the natural log of e is, it's a log with a base of e. Okay, so another way to write this, but not, an appropriate way, I guess, but another way would be log base e of e. So if we're trying to figure out what is log base e of e, we want to know, so we're trying to figure out what is this? We want to know what power can we raise e to in order to get e? And we can raise e to the first power to get e. So this is, I'm trying to show you why the natural log of e is equal to 1. So hopefully this kind of helps to see why the natural log of e is equal to 1. Okay, this last problem here is a half-life problem. So half-life is the time required for any specified property, so the concentration of a substance in the body is an example here, to decrease by half. So we have a radioactive substance. It decays according to this formula here, where Q sub 0 is the initial amount of the substance and T is time in days, this time, not years. And we want to approximate the half-life of the substance. Again, they don't give us an initial amount, but that doesn't matter. But let's pick one. I'll show you that you can pick one, and it doesn't matter. So how about, I'm going to let my initial amount be 100. I don't even need to put units on that. I'm going to say my initial amount is 100. This Q of T is our quantity after T days. Well, if we're looking for a half-life, I want to make that Q of T 1/2 of the initial amount. And notice this is decay. It's radioactive decay, so this quantity is going down. You also might notice that our exponent is negative, which is another indicator that we've got decay here. So we need to solve for T. We've got this equation here, and I just picked 100 as my initial amount. If you could pick 1,000, you could pick 200, you could pick 500. Doesn't matter what you pick as long as you make the ending amount half of the initial amount. So I picked 100, therefore 50 is what I get over here. To solve this, I'm going to divide both sides by 100. And I get 0.5. Well, that's good, right? We're talking about a half-life. So it makes sense that I would get a 0.5 over there. Now I'm going to take the natural log of both sides. And I'm going to use my law of logarithms. I'm going to bring the exponent down in front, make it a multiplier. Okay, we just talked about in the last problem that the natural log of e is 1. So I can just ignore that there, or just kind of get rid of it. And to solve for t, I would divide. I'm trying to isolate t, so I'm going to divide by this. So t would be the natural log of 0.5 over negative 0.0085. Let's see approximately how many days. Now you may be concerned that we're dividing by a negative, and you may think we're going to get a negative answer, but we're not, because the natural log of 0.5 is actually a negative number. So we will not get a negative answer because it'll be a negative divided by a negative. So natural log of 0.5 divided by negative 0.0085 means that the half-life is about 81.55 days, we'll say, 81.55 days. Okay, now one last thing that I want to mention before I sign off on this video is I feel like students start to want to use logarithms when it's not appropriate. So for example, let's say I asked you to solve x to the third power equals 27. Okay, that does not involve a logarithm. The only time we need to use logarithms in order to solve equations is when the variable is in the exponent. Okay, down here, our variable is in the base, not in the exponent. So this, no logarithms. Now, if you were trying to solve 3 to the x equals something like 30, this is when you need to use it. So this is no logs. Don't use logarithms, no logs here. This you would use logs for. Okay, so we use logarithms when we have a variable in the exponent. So I just wanted to point that out real quick before I sign off. All right, well, I hope you found this video helpful, and good luck as you prepare for the final exam.